Some of you have heard Arduino. Have you done coding with Arduino? Have you done some projects? I mean, have you worked with Arduino? Can somebody unmute and say yes or no? I would love to hear your voices. Ah, I have used it a lot before. Nice. Anyone else?
Yes, I used it for line following bot.
Ah, nice. So you made a line following robot, right?
Yes.
Yeah, nice to hear about that. So, one small request is engage with me. I want to hear voices. You have to reply to what I'm saying. You can ask questions in the chat or you can unmute yourself. That's all right. In any language, English or Sinhala, don't mind. Okay. So, before moving into Arduino, so Arduino is one of the basic concepts when we talk about robotics. I think you guys have an interest in robotics. That's why you joined here, right? So this robotics is one of the main and emerging technology in the present world. Can one of you say one application of robotics in the present world you might have seen or heard somewhere? Any one of you? You can, yeah, tell me.
Hospitals.
Yes. Hospitals. Can you specify what exactly in hospital uses robotics?
Surgeries.
Yeah, exactly. So you have telesurgeries, right? I mean, the doctor or the medical officer can control some equipment, and there's a robot actually. The equipment is a robot, and the robot carries out the surgery, and the doctor is the one who controls it. So it's correct. It's actually correct. In hospitals, you have robotics. Okay, and let me introduce you another place where this robotics is applied. Have you seen in? Let's see. Let's try to find out a picture. Have you seen in automobile manufacturing factories? Automobile. You can see the screen, right? You can see the images, right?
Yes, we can see the images.
Okay.
Yes.
Thank you. So this one, let's say this one. Now here you can see the a car is being manufactured, right? This is the chassis of the vehicle. So these yellow color objects, these are robots. These are actual robots. Can you even see a human being somewhere around here? No, right? Everything is carried out using these robots. These robots are, coded, and this can be applied into the specific task we want to get done. So these robots are connected to a main control room, and all the code has been stored there. And there may be a person who is controlling this system of robots, but the entire procedure is carried out by robots. So this is automotive robots. This can be seen in automobile manufacturing companies. Actually, I have to invite to watch something in YouTube. There are a lot of videos in BMW factories, Germany-based factories. These robots are heavily used. You can, in your free time, watch those and get some insight about it. Okay. So, moving on. Now, this robotics is a combination of several engineering disciplines. So, can one of you say what? Let's say like this. So, engineering disciplines. What are these engineering disciplines? Engineering disciplines are, let's say, electronics. Have you heard about electronics engineering? Yes, right? Can somebody respond? Electronic and telecommunication. Have you heard? Somebody?
Yes.
Yeah. So it is one of the engineering disciplines, right? So there are many more. you have computer science and engineering. It is also one of the engineering disciplines. You have electrical, you have mechanical, you have some other fields such as chemical, materials. So these are all engineering disciplines, right? Okay. So I said this robotics is it's a combination of engineering disciplines. That means it consists of several expertise of this engineering discipline. Can you guess what are these? What are the engineering disciplines that is used for creating robots? Can you say one or two? Put it in the chat if you are shy to speak on the mic. No worries. You can start. What engineering disciplines are used in robotics? Basically, what are the theory you have to know in order to build robots? Tell me what? Somebody.
Programming.
Yeah, programming, exactly. So you have to code the robot to get the specific activity done. So that comes mainly under computer science engineering. So computer science students, they do a lot of coding and they do a lot of programming. Like you did in the last few sessions, Python. Python is a programming language, right? So it's basically coding. So these robots should be coded, perfectly coded in order to get the specific activity done. If the code is incorrect or there are, we say bugs. Have you heard about bugs? Bugs in programming, bugs in coding. Have you heard? Okay. Anyone? If it's no, even it's okay. You can say no.
No.
Yeah. Okay. So these bugs in programming means basically there are faults in the program. That means the program will not work according to the way we want. So these codes should be free of bugs. So they should be accurately, precisely coded, and that is coming under the engineering discipline of computer science and engineering. Okay, that is one. We have computer science and engineering as one of the engineering disciplines used in making robots. What else? What else? What is the body of the robot made of? Mainly, most commonly, what is the material? It's made of what? Robots are made of basically metals, right? Many robots are made of metals. So you have to work with these metals. You have to make the body of the robot. You have to make some joints. You have to make some moving parts, dynamic parts. So what is this coming under? Can anybody say? Is my voice breaking?
Yes. Yes.
Okay. Okay, wait a minute. Okay. Now is it okay, right? Now it's okay.
Yep.
Okay, thank you. So what I was telling is, what is this? What is the body of the robot made of? It's metals, right? Basically metals. You make robots out of metals, steel and all. So you
Yeah.
have to work with this metal. Yeah.
Hello, why
Yeah.
your voice is breaking?
Okay. Right. I'll be switching off the video for a while and check whether this thing exists further. You can hear me, right? You can hear me, right? Okay. So what I was telling is these robots have a lot of moving parts. Okay. So these robots have a lot of dynamic parts, moving parts. You have motors, you have joints, you have bending parts, and many things. So, can you guess what is the engineering discipline? We work with these things, the forces and all, maybe the joints, the metal parts. Can you guess what is the engineering discipline? So one is coding. So coding or programming, that comes under computer science and engineering. What is this coming under? Hello? Put it in the chat. Okay. So this comes under mechanical. Mechanical engineering is the engineering discipline. You have this, so you have to know your mechanics very well in order to step into robotics. You should know about these dynamic moving parts, motors, actuators and all. So we will be also touching upon these actuators and motors in the future sessions, and you will get some insights on those as well. So okay, now we have two engineering disciplines that we need to worry about in making robots. One is the computer science and engineering, and also the mechanical engineering. There is another major engineering discipline you should be familiar with if you want to work with robots. What is that? That is what you call the electronics engineering. So this electronics engineering is one of the very important vital part when you start designing robots. If you see these the Arduino, these electronic stuff, these all come under electronics. The sensors, transistors. Have you heard about transistors, ICs, chips, and all? Have you heard? Have you heard about the chip in your mobile phone or computer? It's basically the brain of the computer. Have you heard? Can somebody say an example for a chip? Anything, whether it's right or wrong, it's okay. You can unmute. Just say. Okay. Now, with keeping that question beside, I'm asking you if you're using a laptop to join this session, raise your hand. If you're using a laptop or even a PC. Yeah, okay. 1, 2, 4. Okay. 7, 8.
You have to download the latest version, right?
Sorry.
When we are downloading on a laptop, we have to download the latest version, right?
I couldn't exactly hear your question. Can you please ask again?
We have to download the latest version, right?
Latest version of what?
Arduino.
Yeah, the latest version is okay. Actually, you will find the latest version very easily when you go to the Arduino website. Let's see. You have some stuff on that also. Okay. So, just, yeah, one is saying in the evolution of the second generation computers, transistors have been exactly correct. You know about these generations of computers. So transistors were introduced in the second generation of computers. Okay. So coming back, I have I'm seeing 7 of you. Maybe there are more students. 7 of you are logging in to the meeting or the session with laptops. Okay. So how many of you know what is the processor in your laptop? Raise your hand. Processor or the chip. We basically say that's the chip, but that's not the formal word. We use the microprocessor as a form. Yeah. So you see the count of fans dropped, right? Earlier there was 7, now 4 of you know what is the 5. Okay. So basically the count dropped. Okay. Anyway, anyone of you are raising hands right now? Can you just type what the processor you are using in your laptop? Type and send it in the chat. Shall I call out a couple of names?
Can you repeat, Ayub?
Yeah. If you know the processor in your laptop or computer, can you just type the processor, name of the processor in the chat? Or you can even unmute and say. What is it? I'm going to call out some name. You will summary. Can you just type what is the processor you are using? Ramindu. Right. Ramindu, just type. Intel Core i5 13420H. Okay, same. Namely Ryzen 55,000. Right. So that's correct. Now, this Intel Core i5 13 AMD Ryzen. These are the names of the processor. These are basically microprocessors. And what we came here, why we came here is to explain you about the electronic component. Electronic engineering basically lies in this. If you like break the processor in half, or let's say if you like divide the processor into the basic components, you will find millions of transistors inside this processor. So basically, this processors or the brain of your computer, brain of your laptop, brain of your device is an interesting creation of electronics engineering. And moving on to the robotics side. So these robots also have a processor. Otherwise, this cannot be controlled in our desired way. Like if you want to do something, let's get an example like this. Now, let's say one of you, your school teacher asks you to do something. Let's say, come to the board and solve this sum. Let's say, for example, come to the board and solve this sum. And if you can solve it, you will go there and solve it. Or else you will say, no, I am unable to solve it at this time. So what is the instruction here? Who gave the instruction? The teacher. So this instruction is come to the board and solve the sum. And from which part of your body you understood this instruction? Which part of your body you understood this instruction? It's basically the brain, right? If you don't have the brain in you, you will not understand what the instructions are. Similarly, if there's no brain in the robot, if there's no brain in your device, if there's no brain in your laptop, the laptop or the device will not understand the instruction. So similarly, these robots, we need these robots to do something. We need these robots to do some desired task. So this should come with the brain. So this brain is the microprocessor, and this is one of the creations of electronics engineering. Okay, anyway. So what are the three engineering disciplines? Actually, there are more. What are the three main engineering disciplines you need to follow to make robots? Can somebody unmute and say? I just mentioned three engineering disciplines. Or you can put it in there. Quick.
I have so much background noise here. Can you repeat, please?
All right. Yeah. I just said there are three main engineering disciplines that you should be familiar with making robots. Can you just note down or say what are these three engineering disciplines? They're the main ones. Yeah. Okay. Three engineering disciplines. First one was I will tell you. First one was computer science and engineering. One said programming. So that comes under computer science and engineering. And I said another two more. These are called engineering disciplines. One is computer science and engineering. Second one was, come on. Okay. Second one was mechanical engineering. Yeah, correct. Normally says mechanical. And the third one, these chips are not microprocessors. The brain, what is it? That's electronic engineering. Yeah, correct. Okay, nice. So moving on. So in this session, after this session, you will be getting some more insights into robotics, and you will start creating your own robot when following these sessions. Okay, right. Okay, moving on, you have some, let's say, terms to remember, not to remember, like just to be familiar with. Have you heard about mechatronic system? Mechatronic system. Let me write down. Mechatronic. Have you heard? Anybody? Is it? No. Okay. So can you just guess? It's okay. You have not heard. That's totally okay. But can you just guess from what two words this single word has been made out of? See, I'm breaking this word into two. This one is derived from one word, and this side is derived from another word. Can you say this clearly? What?
Mechanic.
Huh? Sorry?
Mechanic.
Yeah, exactly. This is derived from mechanical. And this one. This is derived from
Electronic.
electronic. Right, exactly. So this term mechatronic is derived from mechanical and electronic. That means these mechatronic systems have a mechanical component and as well as an electronic component. So these are some new words you should be familiar with. Just keep it in mind. There's something called mechatronic system. Okay. So this mechatronic system should consist of a mechanical component and an electronic component. Now we are kind of familiar with these mechanical components. That means you should have some moving parts. You should have some motors. You should have some robotic arms, joints and all, right? Like this. Okay. So this one, can you see Cybots logo? This is some kind of a mechanical joints and all. Okay. So this one is mechanical. And this mechatronic system should consist of a mechanical component and an electronic component. So can you say yes or no for this question? I need your answer. Put it in the chat, yes or no. Is your mobile phone a mechatronic system? Is your mobile phone a mechatronic system? Yes or no? Is your mobile phone a mechatronic system? I have one answer. Some more answers, please. Okay. This seems to be interesting. Different answer. Yes. No. No. Okay. Come on. No. Yes. Okay. Come on. It's like 50-50. Half of you are saying no, half of you are saying yes. I need some more answers. Another 5 more answers, please. Come on. I got another yes. Okay, come on. Right now we have 3 no and 3 yes. Like another no. Okay. One more answer. Oh, 2 more.
What
Is
I couldn't hear.
your- Sorry.
Couldn't hear. Can you repeat?
Okay, yeah. My question was, is your mobile phone a mechatronic system? Is your mobile phone a mechatronic system?
Yes, I.
Yes, I got a yes from the audio also. No and more. Okay. Yes. Okay.
Yes.
Yes. Right. So this seems to be interesting. So we have many of you have said yes. I think yes. Yeah. Majority of the people who answered say yes. Can you say why did you say yes? What was your reason? I'm getting more yes. What was the reason you? It has some mechanical and electronic stuff in it. Okay. Any different answer? Right. Actually, I like the way you try these questions. That's great. You are engaging with this question. Okay. Let's pause it from here, and I'm asking you another question. Have you seen? I need a raise hand. Don't type anything in the chat. Raise your hand if you have seen modern refrigerators with control panels and buttons, etc. With a screen and all. Yeah. Okay. One. Have you seen modern refrigerators with the control panel, buttons, and a screen and all. Okay. Right. So is that a mechatronic system? Is it a modern refrigerator? I'm yeah. I'm talking about only the controlling part, control system part, with the buttons and screen. Only that part. Is that a mechatronic system? Yes and no. Again, yes and no. Right. So this is interesting. Two more answers.
Okay, can you repeat the question, Ayub?
Yeah. So you have seen modern refrigerators. I'm asking, is the controlling part, the buttons, screen, and that part belongs to the mechatronic system? Is that belong to the mechatronic? Yes or no? Yeah. Okay. Right. Uh, Actually, the, now I'm going to see the answer. The mobile phone and the controlling part of the refrigerator, and also you will see similar things in washing machines and all. That controlling part is not a mechatronic system. Am I clear? That is not a mechatronic system. Basically, the mobile phone is not a mechatronic system. So why is this? Some of you said that but some of you said it is mechanical stuff, which is the battery, camera, and yeah, and electronic stuff, software and very. It has mechanical and electronic stuff. Actually, the stuff inside the mobile phone is not sufficient to be called as mechanical. There are no significant moving parts, motors and all. Do you see any moving parts in the mobile phone? No, right? Robot arms or something like that, or motors. No, right? Yeah. The stuff inside the mobile phone is not sufficient to be called as a mechanical system. That is not mechanical. That is not sufficient to be called as mechanical. Therefore, mobile phones, modern refrigerators, modern washing machines are not mechatronic systems. Note down if you want. They are not mechatronic systems. They are, can you guess or have you heard? They are called
Microcomputer.
no, embedded embedded systems. What are they called? Embedded systems. Can somebody can say the word? That is called embedded system. So you know, it compares with a moving parts for the mechatronic device. Yeah. Uh, Compulsory means not actually moving parts. You should have some part, some kind of a mechanical system. Yeah, mechanical system is basically you can say that they are moving parts or maybe motors or maybe arms or something. But you don't see such thing in the mobile phones, right? You have a very big electronic component. That's all, right? That's for sure. That's there. And you don't have the mechanical component in the mobile phone, right? So we cannot regard it as a mechatronic system, the mobile phone. And the embedded system, what we are talking about here. Now you know some examples with embedded system. Your mobile phone is an embedded system. the modern refrigerators, the modern washing machines, they are coming under embedded systems. I mean, only the controlling part, the button panel, the screen, that part only comes under the embedded system, not the whole washing machine, not the whole refrigerator. You have some other mechanical parts. I mean, there is a compressor, some the mechanism for cooling. That is a mechanical part. I am just focusing on the controlling part, the buttons. That button part comes under embedded systems. Okay, is it clear, or do you have any clarifications, doubts on that? If you have doubts, you can unmute and ask, or you can put in the chat. Someone is raising the hand. That's because of an earlier thing, or do you want to get something clarified? Yes, mobile phones are embedded systems. If you have any questions, you can just ask now. Are you all good? Shall I continue? Yeah. Can you explain what is embedded system? Embedded system is, let's see like this. Just get the refrigerator example again. If I ask you, showing a refrigerator, yeah, exactly. If I ask you showing a refrigerator, what is it? What will you say? Will you say it's a computer, or will you say it's a refrigerator? Let's see. Let's get an image. Wait. Okay. So this one. You can see the screen, right? This part. You can see the image, right? This one. This is something. Is something. Right? These are buttons, if I'm not mistaken. Yeah. So this one. If I ask you what is this? What is this thing? What is the big box? What is this? This is a refrigerator, right? You don't say this is a computer. You don't say this is something. You don't say this is something with buttons, something with a screen on it. You don't say like that. Yeah. This is a refrigerator, but you have some kind of a hidden computer in this refrigerator. Do you agree with that? You have some kind of a hidden computer, hidden processor, and some coding is included in this. That is hidden inside this refrigerator, right? Are you clear? Yes. So if you have some system with a hidden computer, with some hidden coding, with some hidden electronic systems, that is an embedded system. Okay, are you clear? I'm talking about only this controlling part, not the cooling mechanism and all. Okay. Yeah. Now this is a good question. But how will the computer work with low temperature? I think one is asking, how will the computer work with low temperature? So this computer is not inside the fridge. This computer is not inside the refrigerator. This computer does not get the effect of coldness. This is just a, let's say, you have box like this. No. Let's see. Now, okay. Now, imagine this kind of refrigerator. Do you see something? Let's say you open this refrigerator. You just open these doors of the refrigerator. Do you see any parts of a computer inside this? Do you see? When you open this refrigerator, when you open the doors, do you see parts of? No, right? Yeah. So this computer is not inside the refrigerator. This is some additional component that is connected to the refrigerator in order to get some tasks done. So what are these tasks? You can control the coldness using this computer. Is it clear? Now, yeah, I'm asking because computers should be in a normal temperature without being in high or low temperatures for functioning. Okay. Okay. So, can you work with a computer in the normal room temperature? Yes, you can, right? So, you're keeping the refrigerator in the normal environment. So, that computing part, the controlling part is also in the normal temperature. There is no effect of the coldness in this controlling part. There is no effect of the coldness in the computer. And another thing is it a really, yeah, exactly. This is a really small space. That's what I told you earlier. This is a hidden computer. You don't have like the normal computer, let's say computer. If you say computer, this is what you get into your mind, right? You have a monitor, you have a big box CPU, keyboard. But the main purpose of this is computing. Computing means calculating or doing something, right? The main purpose is that. But do you need everything for that purpose? Do you need a speaker to run a program? Do you need a keyboard to run the program? Just to run the program? No need, right? It's sufficient to have just 2 or 3 buttons. You can have, yeah. So the main purpose of that, let's say the main purpose of the system in this is computing or some following a program, following some instructions. That's it. Like you don't need the conventional keyboards, mouse and all. You have just a small space. Some chips are there, 2 or 3 buttons are there. So you can say that is a computer. But that is hidden inside one of the major instrument, major appliance, and that becomes an embedded system. All clear?
Okay.
Okay, nice. So everybody's okay with that, right? Okay. So some questions were there. What is the difference between the embedded system? You're okay with it, right? Basically, embedded system is something, some computer hidden inside a major appliance, and mechatronic system is some instrument which consists of mechanical component and an electronic component. That is the difference. Okay, all right. Okay, then so we can just go to the internet, search some more information about that. Okay, so just watch some videos in YouTube. You have plenty of videos. You can just watch when you're free. What are these mechatronic system? What are these embedded systems? And also, yeah, and another thing. Most of you are using smartwatches. Right? Now, if you understood it perfectly, tell me whether smartwatch is an embedded system or a mechatronic system. A smartwatch, embedded system, correct. A smartwatch is an embedded system. And another one. Mm, uh, have you heard about multifunction steering? Multifunction steering in vehicle.
Multifunction what tire?
Steering wheel. Multifunction steering wheel in vehicles, in cars, modern cars, and all. Wait, wait, multifunction steering wheel. So this one. So this one, yeah, this is what you call the multifunction steering. The primary purpose of the steering wheel is to steer the vehicle, right? But you have some buttons. You can control the volume, control the AC, and you have some functions such as cruise control and all. So you have several functions of the steering wheel. But as soon as you see this, you will not say it's a computer, right? It's a steering wheel. But when you dive deep into this, you will see some computing parts. You will see some processors going on in this. You see some buttons. So this system is a what is an embedded system. I think you're clear with that, right? Yeah. Increase the volume, decrease on the radio, take a call, Bluetooth, yeah, many more. Yeah, many other functions embedded in the steering wheel. That means hidden in the steering wheel. So this one is an embedded system. Okay, I think you're clear with that. If you are clear, just raise your hand and let me know. Okay. Yeah. So moving on. I'm just telling you some things to do your homework. Okay. You can find about this. Just note down. First thing is mechatronic system. Note down. You should like get familiar with this. Find some information. First one is mechatronic system. Second one is embedded system. Now we are kind of familiar with those two. Okay, right? Next one is programmable logic controllers. Programmable logic controllers. I'm not going to describe it right now. Just go through the net and get familiar with this term. Programmable logic controllers. And also find some organizations or companies which design robots. Do you know? I mean, have you got any ideas what are the companies designing robots? There is one famous company. Just say if you know. Exactly. Boston Dynamics. Nice. So this Boston Dynamics is one of the major companies, or very popular companies, which are into robotics. They have made some. You can find. I'm not like going to destroy your imagination. You can just go to the Google somewhere. Yeah, Boston Dynamics Diligent Robotics. Yeah. So you have some homework to do. Find about that. Okay, let's move on. So now I told you about microprocessors. Right. Let's see. Okay. So you can see the slides, right? So we are going to deal with Arduino, right? So this whole sessions are about Arduino. So what is this Arduino? If I read this, Arduino is an open source electronics platform used to create interactive projects. Oh my God. Arduino is an open source electronic platform used to create interactive. So basically, Arduino, using Arduino, you can create various projects, various interesting tasks can be done. It's like this. You code, you program the Arduino board, and this Arduino board will do some task for you. You code it, and this will do some task for you. That's the simple idea of it. And it consists of hardware, software. Let's see what is the software part. So hardware part is easy, right? These boards are all hardware. Let's see what this software part is. And that allows users to program and control various different. It's like this. Let's say you have an LED. And this LED, you need to on, off, on, off, on, off. Just like blink, the blink circuit. You're on, you're keeping the LED on for 1 second. You're keeping it off for 1 second. And this repeatedly goes. If you're going to do this without the Arduino board, how can you do? You have to connect the battery and LED into a switch, and some person should be there. That person should be that person should on the switch, on the switch, on the switch. On. So that's a like tedious task, right? And that person will go away after 3 minutes. So using this Arduino, you can program the LED. No, I mean, you can program the Arduino board and make the LED blink for 1 second, LED on for 1 second, and off for another second. That's a very simple, that's a very basic thing you can do with it. You can code the Arduino. It's like this. You give the instruction on the LED, wait for 1 second, then off the LED, wait for another second, and repeat this cycle. It's like that. Are you clear with that? Excuse me, can you hear me? You are clear, right? Yes or no? If you have any doubts, you can ask. You can raise your hand, you can unmute, or you can put it in the chat. Up to now, you are clear, right? Hmm. Can you yes or no? Okay. Okay. So this one. So I was talking about the brain of the computer. So this Arduino board is the brain of anything that you will be creating here on this. So if you create a small robot, and the brain of that robot is this Arduino board. Okay. So there are not just one type of Arduino boards. Here you have three, but there are several more. The first one is the Arduino Nano. It's very small, and that can be used for. If you want, you can note down this. What I'm saying. Okay. The Nano board is a smaller board, but it's powerful. You can use it in smaller robots or smaller projects. And if you need the project to be more lightweighted, you can use the Arduino Nano. Okay. So this one, the one in the middle, Arduino Uno. You might have heard this. This is the most common Arduino board, and this is very suitable for learning purposes. So you will be using this Arduino and the Arduino Mega. Can you see this small black color lines? They are called pins. You have a lot of pins in Arduino Mega related to the Arduino Uno. So you can create large projects, or you can create more complex projects using Arduino Mega. Right? Okay. Okay. It's not small enough to say nano. Yeah, you might be thinking the nano scale is a very small scale, and this board should be very small to call nano. It's not like that. Just it's the name. This is nano, this is uno, this is mega. And if in that sense, this mega board should be like very large, right? Don't worry about the names. This is nano, this is uno, this is mega. Okay. So next one. So this is your controller. This is your Uno board, Arduino Uno. I'm just rushing through this. Just I want to give you a small idea about this. So this one. What are the parts of this? First one. This one is one of the major parts. I mean, one of the major parts. There is another major part which I'll be going through later. This one is the USB connect. I'm going through this way. Okay. So this one is the USB connect. Without a computer, there is no way you can write codes on this. So you need to connect this board to the computer using this USB connector. Using wire, you can connect to the computer, and from that, there is a software. You can write your code and upload it onto the board. So this connector is very important in order to modify the code in the Arduino. And also, when you're testing your code, you're testing the project in the Arduino board, should give some kind of a power to power up this Arduino board. And that power is also given through this USB connector. Okay. That power is also given through this USB connector. Right. And this one, reset switch. It's clear right from the name, reset. You can start the code all over again once you press this. You press this and the code will start to execute from the first line itself. Let's say you are somewhere here. This is the code. You are somewhere here. You press the reset switch and this will jump to here and it will start to run from the first line. Okay. So digital things. These are like small holes. You can insert wires into this. You can insert other basic electronic components in this and get the things done. These are digital things. We have some LEDs and this one. This black color rectangle, that is the main part of this Arduino board. That is the brain of the brain. Earlier I said this is the brain of your project, and that brain is powered by this brain. This is called the microprocessor of the microcontroller. Microprocessor of this, Arduino board. So earlier you said some names of microprocessors, right? Somebody said i5 12 gen something, and another one said AMD Ryzen. So there's a name you can see here. This one is called AT, Mega, at Mega, three, two, eight. This is the name of this processor. It's just like AMD Ryzen or Intel i7, i5, something like that. So this one's name is AT Mega at Mega 328. This processor is known as, the name of the processor is at Mega 328. So we have some analog inputs. Let's see what are these pins later. Digital pins, analog pins, and all. And power port. This power port, this one also I said we can give power from the computer. But we need a computer to power this port using this USB connector. We have a different power source. We can use the power port in order to power up the Arduino board. And also we have some voltage regulators, differentiators, USB. These things are not like ahead of the scope. So just keep in mind about the basic parts of the Arduino board. Okay. Up to now, are you clear? Okay. Digital pins and analog input does not have any function to do in the Arduino. One is asking the question, why they have included this? Actually, you will understand about this question, understand the answer for this question, maybe in the next session. But I will just tell you, these digital pins and these analog pins are the lasers where you connect other components into the Arduino. It's like this. You have some USB connectors in your laptop, right? You can plug a pen drive, you can charge your phone. There is a small hole, right? USB connector. Similarly, these behave in the same way. You can plug a mouse to the laptop, right? Similarly, you can plug another equipment, another, let's say, sensor or something, into the board using these pins. Without these pins, you cannot make use of the Arduino board. Are you clear about that? You will understand about this. What are the numbers near the okay. You mean 13, 12, 11, these, right? Okay, yeah. So, the numbers. Wait. So, can you see, there is a small hole here, and that is termed 0. There's a small hole here, and that is 1. This is 2, like that. So, these pins, you have 13 digital pins in the Arduino Uno board. And each pin is given a number. That means that pin can be uniquely identified using the number. If you say the 5th pin, that is this. If you say the 8th pin, that is this. You can ask the computer to switch on the 5th pin, and this 5th pin will start to work like that. That is the uniquely identifying method of the pins. Are you clear? Okay. Right. Any other question? This Sunday. Are there any yeah, wait, I will inform you within the meeting. Are there any virtual Arduino boards like in the internet? I guess in the technology, right? In a few moments, we will be checking on virtual Arduino boards. So stay tuned. Okay, next up. So the attendance link will be notified to you in a few moments. Okay, so now we should know how to install the Arduino IDE. So this IDE will be used to code the Arduino. So in the last session, to install the Python IDE, right? Similarly, you write codes on the IDE and you upload it using the Arduino IDE. Upload to the board using the Arduino IDE. Let's see. If you want, you can take a screenshot or something and you can try it. I'll just take you through. So look it carefully. I'm going to the Arduino. So this is the, you can see the screen. Right? This is the official website of the Arduino. And here, now I'm in the official website of the Arduino. You can even paste this link Arduino.cc in the software. Here, the software tab is pretty. You have some download options. You can download it to Windows, Linux, or macOS in Apple computers. So using this, let's say a Windows 10, and just clicking on this, just download here, just download, and it will ask you to download. Okay. Are there any questions regarding the installation? Or do I need to take you through again? Tell me, are you clear about it? Yes or no? Yeah.
Can you take it through again?
Okay, sure. So it's like this. Just type Arduino, and the first result will be the Arduino official web page. You just go for that Arduino.cc. Okay, this is the official web page. Then we have a tab called software. Here, software. Click on it, and you have several download options here. This one here. So you can download it to Windows or Linux, Mac OS for Apple, likewise. Now I am choosing Windows 10 and 11. Just click on this. Okay. Now you will be redirected to a website like this. Just click, just download. Click on this, just download. This one, just download. Okay, I'm clicking this. And again, you will be directed to this. Again, click, just download. Then this will be downloaded. Okay. Okay. Is it clear? It's clear, right? Please respond. You can take a screenshot of this and try later. we have the arduino.cc. This is the web page URL. You can just go there, go to the software tab, and you have download options. You can choose what version you need, and then click just download in the two web pages you will be receiving. Okay, it's clear, right?
Yeah, clear.
Okay. So next, now we are going to look into some basic electronic components. So these will be used by you. Yeah, great. Install. Okay. So these will be used by you in future projects and other, let's say, robots you are making. These are the basic electronic components. So electronic components are the building blocks of all electronic circuits. We will be manipulating this soon and creating incredible projects in the future. Okay. So these are very simple. You might have heard about this. LEDs, light emitting diodes. So this one, the type of diode. Diode is a new word. You can go to the internet and find what the diode is. Diode that emits light when current flows through it. That means you can just plug it into the power supply, not the power supply, and you can give some power to this, and this will light. It will give a light, blue, green, or red. Okay. So these are used in displays, indicators, and light effects. So just look in your laptop how many LED indicators are there. When you plug into the charging, there is a small LED lighting up. Likewise, these are used as indicators to indicate something. That LED just indicates that the device is charging. Likewise. So the resistor, next one is the resistor. This is a fixed value resistor. Fixed value means the value of the resistance will not change with any other influence. So the resistance value is not changed. So what is this resistance? If you say, when you take an LED, if this LED requires a small current, okay? If this LED requires a small current to light up, but you have some sort of a big current with you. You have some sort of a bigger current source with you. So if you just directly plug it into that power source, this LED might go, will burn, right? So to prevent that, we are using resistors. Basically, resistors control the flow of electric current. Okay, right. So resistance is measured in ohms, and you can see there's some color coding system is there: blue, black, the red, and yellow. And this there's a color code. You can uh, get to know with the color code and find the value of the resistor. So you have to use the correct resistor when you are using them in the future. You should get
Excuse
the
me, Ayat.
color. Yeah, tell me.
Each color has a value, no? For the resistors.
Not like that each color has a value. Yeah, it's kind of true, but this combination gives you a value. I mean, we cannot exactly say that red is for 10, black is for 20. It's not like that. If this combination is there, that combination as a whole gives a value. Okay.
Okay.
Okay. So you have to use the correct value of resistance when you are working with them. So as I said, they are essential for protecting LEDs, controlling. For protecting LEDs means you should make sure that the LED will not burn when you connect it. Okay. So this is a fixed value, or you can call it permanent resistors as well. And this one is a potentiometer. This potentiometer is a variable resistor. Same purpose as the fixed resistor, but the difference is you can change the value of the resistance by some mechanism. So you can use like take this one commonly used in brightness control, volume control. Have you seen volume controls in radios, let's say, in setups and all, you have volume control. So you can rotate this knob and make the volume up or down. So basically what you are doing is varying the resistance, a change in the value of the resistance by turning the knob. And this one will also be useful for you in order to get a variable resistance or variable current supply. Current flow actually, not the supply, current flow. Right. And this capacitor. There are several types of them. Let's see. This one stores and releases electrical energy. This capacitor, when we connect this inside the circuit, it can store some small amount of energy and it can release it when required. It stores energy and releases it. And in the next, and it even can charge itself and release it when required. It's not like a battery, but it can like store a very small amount of energy. So this one can store energy and release it as required. So this one, cream color one is a ceramic resistor, and these are plate resistor. I know there are various types of resistors. So the potentiometer, does the potentiometer measure potential energy? No, the potentiometer does not measure potential energy. This potentiometer is a variable resistor. You can change the resistance and get the required output. How much electrical energy can the average capacitor store? Actually, it's a very small amount and varies with the type of the capacitor. There is no such average capacitor, but it depends on the type of the capacitor. Right. Next one, this buzzer. Buzzer is something you can get a sound, produces sound when powered. There are two types of buzzers, namely active buzzers and passive buzzers. Usually alarms, notification alerts. Uh, have you heard about the UPS, uninterrupted power supply? You have in computers. So there's a beep sound. That beep sound is given by buzzers. Okay. So next, DC motor. I think you are very familiar with this. So this is a motor, just a DC motor. Converts electrical energy into rotation work. So if you need to rotate something, you just give a power to this. This will start rotating. This ones we will be going through it again. This L29, L29. These are some components which you need to power up the motor, and they will be used in the later session. Right. So next one. So are you clear about these components? Just basic components. You can like in your free time, just go to the internet and see what these components are and how you can connect these two circuits. Just you can do your own work. Okay. So next up, introduction to simulation software. And one Malli was asking, are there virtual Arduino boards? And this will take you to where the virtual Arduino boards are. Okay. So this simulation means that, you know what simulation is? It means you are doing something, but it's not the real one. Like this. Have you played flight simulating games, driving simulating games? I was talking about simulation software. So, have you played driving simulator games or flight simulator games? Probably you might have played, right? So, in driving simulator games, do you actually drive a car? No, right? But you get the same experience. Same means sort of same experience. So, that is what you call a simulation. Here, we will not actually connect the circuits, but virtually we will be trying each and everything and get the output virtually. And then, if it's all right, if things are going well, you can connect it in the actual game. Right. So, simulation software is a computer program that helps us to create a virtual model of real world things. Create a virtual model of real world things like machines, factories, weather, or even human bodies. Yeah. It allows us to test different situations without doing them in real life. So this will save your time of connecting and testing and all, money if things get burnt, if circuits get burnt. So it will be save an effort as well. So it's the same thing, safety, cost effectiveness, and nature. So we have some insights about uh, simulation software now. Now let's see what the simulation software we are going to talk about. That is called Tinkercad. So now this is the place you will be getting a whole lot of homework. So you can log in. I think you have already got the Tinkercad links, right? Tinkercad accounts. So you can try on with them. So this is a free website. You can let's see. Let's go to Tinkercad.
I've used this before.
Sorry.
I've used the Tinkercad before.
I have used. Okay. Okay. So I'm going to create and then search it, and you will get an interface like this. We have all the components that is required to simulate the circuits. So here and this one was asking, are there virtual Arduino boards? Yeah, this is the virtual Arduino board. You can connect things. You have the reset button, USB connectors, pins and all. You can play around with this. Okay, and we have other components. This is known as a breadboard. We'll be working with these breadboards actually in future sessions and know how the connections are made and all. Here LEDs. Let's connect something. Okay, wait. Okay. Let's see power supply. Okay, we have a power supply and getting the wire from the positive and connecting the positive. Okay, right. Now I am giving a voltage of 5 and a current of 8. Start simulation. See, when I started the simulation, here you can stop it. Here, here the button called start simulation. Now I connected the LED to the power supply. Now I start the simulation. You can vary the voltage and check what happens to the LED. See, then it's basically the simulation. So you can try about making things, connecting this different stuff, and just play around with this. Okay, you have a whole lot of components. Right. So first question, both Tinkercad and Arduino are two different topics. Because Tinkercad is used to different 3D modules, why you have included Tinkercad under Arduino? So that's a good question. Actually, 3D modeling also can be done, but here we are going to simulate the circuit. So let's say if you are making something, you are making a robot. So is it good to connect the robots using the actual components, batteries, boards, and all at first without just testing it somewhere else? So that for that testing purpose, you need the simulation software.
Lakindu,
Yes.
can you hear me?
Yeah, I can.
Yeah, sorry to interrupt. There's a small announcement.
Okay.
Mandila, I think those who joined the previous sessions know about this. In every session, we are taking attendance using a Google form. So that form will be shared in the WhatsApp group in a short time. We will let you know. For those who don't know about this, it is how we take your attendance. Then you just have to fill out the form as soon as possible. You will be given like 5 minutes to fill it. It is enough because it's just a small Google form, just through 2 or 3 questions. So put your name and I will announce a code now, and you have to enter the code correctly. That's how we are going to take the attendance and submit it. That's all. So I will announce the code now. The code is 9591. Let me repeat the code, 9591. So you better write it somewhere, write it down somewhere, or do something like that. And when the form is shared in the WhatsApp group, you can fill it out. I will announce the code again one final time, 9591. The form link will be shared, Malli. Don't worry. Just in few minutes it will be shared in the WhatsApp group. Hope you all understood. Yeah, that's all. Thank you, Lakin. Carry on.
So what I was telling was, using the simulation software, you can just test it on your computer virtually, and if everything is all right, you can start connecting the components actually or physically. So knowing about this Tinkercad or simulation software is very worth when you are doing Arduino projects. So that is why we have included this under Arduino. First, you can simulate it virtually and then start connecting. Did I answer your question? Yeah, okay, nice. So we have come to the end of the session. Do you have any questions, clarifications, ideas, suggestions, anything? You can come up with them now. Are you clear about what was taught, what was discussed? Any questions, any concerns? You can put it in the chat or you can unmute and ask. All right. Okay, all clear, right? Nice. So, we back some small. So, what are the things I mentioned? Things means what are the homework I gave you? First thing, I just asked you to get familiar with certain words, right? A small announcement. Now the form is there in the WhatsApp group. You can just quickly fill it. Make sure everybody fills it, okay? It's there in the WhatsApp group. Okay, everybody fill it and come. So, the form will be closed in a short time. So make sure to fill it. Everyone fill the form.
Ayya, what's the code?
9591.
Make sure that everybody fills the form. Your attendance will be recorded.
Mallila, I have shared the form link in the Zoom chat too, so you can use it or the WhatsApp either.
Thank you very much, Dinura Genege Ayya and Hiran Dharmapala Ayya, for the valuable lecture delivered today. We are confident that our Cybots participants had an insightful session on Arduino. These two Cybots 2025 sessions on Arduino will undoubtedly serve as a strong foundation for many of our participants as they step into the world of robotics and embedded systems. Once again, I would like to extend my sincere gratitude to all the organizing committee members from OREPA and the Royal College Computer Society for making these sessions possible. A special thank you to all the participants for your dedication and engagement throughout the session. Your commitment will not go to waste as you will gain valuable knowledge, hands-on experience, and a well-recognized certificate at the end of this course. Moving forward, the next session will dive into robotics, making deeper into robotics, marking the transition from Arduino fundamentals. This session will most likely be held physically, but the final decision will be based on the feedback collected through the Google form. Further details will be shared in our WhatsApp group. We encourage you to share this course with your friends and invite them to join us in the incredible learning journey. Let's meet again in the next session of Cybots 2025. Thank you once again to everyone for being here, and a special thanks to Dinura Ayya and Hiran Ayya for today's lecture.